Hello and welcome to the Applied Deep Learning course 2021 at the Vienna University of Technology. In this course, you're going to learn a lot of things about machine learning and more specifically about deep learning and how you can apply it to solve challenging tasks that just a few years back have been considered extremely hard or even unsolvable. My name is Alexander Pacher and I will be your instructor for this course. So let me introduce myself, a few words about me. I'm a software architect at eNote in Germany, here in Berlin, and we're building intelligent sheet music, so it's a mobile application for musicians, of which I'm myself one. So I'm an active musician, I sing in an a cappella group called Roots and Roots, and also at the TU Wien choir. A few years back, I did a PhD in the field of optical music recognition. It's basically, in a nutshell, when you take an image of printed music scores, you run it through this optical music recognition pipeline, and you get a machine-readable version of that music score that, for example, you can play back to you. During that PhD, I used a lot of deep learning techniques to solve this task, or at least to work on this task. It's not fully solved yet. And I thought the knowledge that I gained during my PhD was really useful, and I wanted to share that knowledge with you. So let's talk about deep learning. This is the reason why you're probably here, because you heard or you read the title Deep Learning or Applied Deep Learning and you went, woohoo! It's super cool, it sounds really great. I'm gonna be rich, I'm gonna be famous, and I'm gonna solve all the problems with deep learning. And well, you were not alone with that kind of sentiment. When you take a look back a few years, in 2018, the Gartner Hype Cycle about which technologies are kind of coming and where they are, they actually put deep neural networks or deep learning onto the peak of inflated expectations. So 2018, everyone was absolutely hyped about deep learning. And I hope that in this course you will understand why it's such a useful technology, how you can use it and apply it to your problems. Actually, I want to give you a kind of an updated view because this was 2018. And I hope that we will not fall into this trough of disillusionment, but actually that we will come onto this slope of enlightenment soon, because it's already 3 years ago that they assessed it in this way. When you take a look at the Gartner Hype Cycle 2019, I would say the trend definitely continued. And also here you had about 6 different technologies that are here, for example, Edge AI, Explainable AI, or Emotion AI. And it hasn't changed. 2020, same thing. Explainable AI is already over that peak of inflated expectations, but there are a lot of new technologies and specializations, if you will, relating to machine learning, artificial intelligence, and deep learning that are still coming on our way and that are extremely hyped nowadays. When talking about expectations, I want to ask you something. Does any one of you know CRISPR? Have you heard about it before? It's the genetics scissors, so to speak, with which you can manipulate the DNA in order to make it have certain properties, and it's very useful and it has revolutionized its field. And I think deep learning in the field of computer science has a similar potential, or actually already has transformed our field quite significantly. But talking about inflated expectations, I want to show you this short clip by one of my favorite comedians, John Oliver.
Could CRISPR give us unicorns?
So, we're getting creative now. So there are examples of animals that have single horns in the middle. So like the rhinoceros has one at its nose, but there are other ancient rhinoceros that have it in the middle of the head. So anyway, I think that you could get a single horn on a horse by looking at horns in other species.
So it's in the realm of possibility.
Yes.
It's in the realm of possibilities. I think this is a great word at the end here. So many things are possible, and I would say with deep learning also many things are possible, and this course is trying to give you somewhat an understanding of what is actually possible and what not. Because people can be afraid of what's coming if they don't know anything about it, and they're afraid that artificial intelligence will take over the world, but the reality can sometimes look a little bit different. So, in a nutshell, the goals of this course: what can and cannot be done with deep learning. I will give you a broad overview of the field, talk about specific challenges in that field, and how the recent advances in the last couple of years have evolved and been able to overcome many challenges that have been thought to be extremely hard to solve or even unsolvable. You will gain hands-on experiences on how to pull off a deep learning project. Deep learning is not a jack of all trades, so I think it's very helpful to actually do something in that field, play around with it, and understand what is possible and what is not possible. And finally, whatever you achieve here, you will have to present it to your fellow students and to me, because I think it's kind of sad if you create something that is fantastic, but then you cannot communicate it with anyone and you cannot show it to anyone. That's why I want you to also actually tell everyone and demonstrate what you've achieved in this course. About this lecture, it is called Applied Deep Learning. I've already said a few words about deep learning. Now I want to say a few words about applied, why this word is here. It's applied deep learning because you will do most of the work in this course. I strongly believe that you will learn the most when you actually get your hands dirty, when you play with something, when you fail, when you make mistakes, and you learn out of them. And this is the main goal for this course, that you actually get hands-on experience here and understand what's behind it, why is it working, why is it not working, etc. So how will you actually gain this knowledge and this experience? This is the center of this course, is a project. That's why it's called Applied Deep Learning. You will have 3 assignments in which you will pull off an applied deep learning project of your choice. So you have 3 assignments. You will at the end create a written report about what you've done. You will present it in class, in the last 2 lectures of this class. And finally, you will gain a lot of theory in these lectures here from me that will help you to solve your problems and the assignment that you choose for yourself. Let's talk about the project. You will be working on a project for the whole semester, and you will pick a topic that you think is interesting. I don't want you to develop something just for this lecture. I mean, it's the most likely case that this will happen, but I still want you to be passionate about it. I want you to be interested, that it's challenging and something that is useful to you, that you want to work on, and that is something that you want to work on. So you will pick a topic and you will pick a project type. As of the project types, there are 4 different project types. Number 1, bring your own data and using an existing approach. The idea is here that collecting data for a deep learning project or for any machine learning or data science project is of the essence. And it's actually underestimated by a lot of people. So the goal of this type of project would be that you gather data. And sometimes gathering data can be extremely complicated. So you will be creating data, or it's just a lot of effort. So you will be collecting data and then run an existing approach. There is a lot of existing code already available online that you can use and then apply to your data. So the focus would be to collect the data or generate data if need be. The second type of project is bring your own method, but train on an existing data set. There are, I would say, almost equally many data sets already available as there are approaches that work on these data sets. The goal hereby would be then to kind of flip the game around. So you will be choosing any of the existing data sets. So this part will be solved, but then you would have to bring your own method. Take an existing approach that has already been shown to work well, play around with it, train it, improve it, and see where you can get with that. You don't necessarily have to improve what's out there, but I really want you to play around with it thoroughly, fully understand the approach, and train your own networks, etc. The third project type that you can choose from is called Beat the Classics. Machine learning has been shown to work great for many problems. However, it's not a jack of all trades, as I've said before, and it does not solve all problems equally well. There are many problems that have great solutions with non-machine learning methods. For example, line detection. There are a great number of solutions to just detect lines, and when you pick a project of the type Beat the Classics, your goal would be to take a problem, build a solution that works with machine learning, and show that it's superior to the solution without machine learning. So that is the baseline, whatever non-machine learning approach you want to compare with, and then you have to demonstrate that whatever approach you choose is better and works better. And finally, the fourth category is called Beat the Stars, where you would try to improve the state of the art. In the last couple of years and also this year, there are several PhD students in the course. I would, if I have to kind of put my own thoughts in here, this category is mostly reserved for them. Feel free to try it out, but I can tell you this one is the most challenging part. So you would choose a project, a type, a data set, whatever, that is out there and where there is existing research on it. And you would try to find what is the state of the art, what is the solution that works best for it, and try to beat that solution. Improve it somehow, find a way how you can apply the knowledge that you've gained throughout this course to beat the state of the art. And ideally, you can publish a paper about this afterwards. In the last 2 years, there have been several papers that were at least inspired or originated from this course. So that will be Beat the Stars. How does grading work in the course? The grading will be immanent, so your project will be graded continuously throughout the course. You have 3 assignments, the report and the presentation at the end, and each of these 5 parts will give you up to 10 points. And the criteria by which you will be evaluated is obviously the result, what you've achieved, but I would also like to give points for creativity, complexity, and also something that is not that common in many university courses, code quality and your presentation. So for results, I added an asterisk here. Failure is acceptable. If you try something out and you can show that you followed the right path to solve it, but the problem itself is just unsolvable, then failure is kind of acceptable. If you try to beat the classics and you implemented a great approach that still doesn't outperform the traditional methods, it's fine. It would be then failure in terms of that project, but it's acceptable for the course because the goal is not to improve the world, but for you to learn as much as possible. Creativity and complexity obviously will be part of that. If you come up with a clever solution for an existing problem, it's much more interesting than taking something that is already out there where you just copy paste it, play around with it a little bit and then hand that in. Code quality is something that I personally, as a software engineer, think is extremely important and often underestimated, because there are always at least two people reading your software. It's you and you again a month later. In this particular case, I will also read your software, I will go through it, and I have to understand what you're writing. That means I want you to properly document your code, use proper names for your functions and variables, and make sure that your code is well understandable such that I can understand what you're trying to achieve. It might also come in handy when you ask for help and want me to have a look at your code. If I have to spend an hour to understanding what your code base does, I will not be able to do that. So please really make sure that you produce proper software. And finally, presentation. It's not enough to just present it in any way. It should be appealing and it should be interesting to listen to. Because if you have a message and you don't know how to properly communicate it, no one will listen to you. That's why I think the way how you present your results is also extremely important. And it applies to all parts of your project. If you give me an unformatted text file with no headers and just some badly written README, it's much harder for me to understand what's going on as opposed to a proper README file with headlines, with an instruction, how to reproduce the results, etc. This is part of the presentation of your code and the presentation of your work. The grades will be fairly standard, so you have to have at least more than 50% of the points to pass this course, and I would say it's a kind of standard grading scheme here for this course. There are 3 assignments that you will work on that build on top of each other. The first one will be the initiation. So you will come up with a topic, you will gather data, try to research existing approaches, and then plan your work. This one seems to be easy, but trust me, to do proper research is really hard and challenging. So start early with that part already, because then you will benefit later on because you have a lot of things that you can build your work on top. Assignment 2 will be hacking, where you will implement your idea, you will run the training, you improve your methods, and you will optimize as much as you can within your given time frame. The project here is time limited till the end of the semester, so you will only have a certain amount of time, and when you train a neural network, it can take days for one training round to complete. So this is kind of an open-end problem. I just want you to do it to some extent in the assignment 2. And finally, deliver. I want you to build a small application that actually runs your machine learning model, ship that, and demonstrate to us how it actually works, how we can use it, and how anyone, ideally in the world, could see what you've achieved easily. One example could be a small web application if you have a problem from the image domain, where people can just drag and drop an image, and then your model will run on it and produce and show some results on it. That would be a great deliverable for assignment number 3. Assignment number 3 obviously also contains the report and the presentation, but that's kind of on top of that because it's going to be the end of the semester. This is the schedule for this semester. As you can see, there are a lot of topics, and I'll take the liberty to rearrange them if I see that some of your projects require the knowledge earlier. So it can be subject to change, but mostly I will follow this plan. As you can see, there are 3 deadlines for your assignments that will always occur before one of these lectures. The first deadline will be on the 27th of October, which is already quite soon. It's just around 3 weeks from now. And then there's a second assignment deadline before Christmas. So up until then, you will have time to hack away and do the second assignment. And before the end of January, you will have to finish assignment number 3. And as you can see here, there are 2 slots at the end, the 20th and the 27th of January, where you will be doing presentations. The logistics for this course are as follows. The entire course will be online in this format here. There will be weekly lectures on topics that are useful for your project in exactly this form as you can see it now. Additionally to that, I think it's very important that you also have a channel where you can ask me easily. Therefore, there will be weekly Zoom calls where I will join, and it can take half an hour or an hour depending on the number of questions that you have or that you want to discuss about the lecture, about the material, or about your project. And these will be fixed time slots Thursday in the afternoon. At the end of the semester, you will be giving your final presentation about your project. That will also happen online. That will be a 5 minutes video in a similar form that I'm doing. So you will be recording yourself and we will watch that together in classroom. It means that you have to prepare this video. Please make sure that the quality of your video is good. Upload it to YouTube, I will collect them, and then in the last 2 courses we'll actually watch them together, and then immediately after each presentation you will be able to discuss about your project, answer questions from your peers. And I think it's those 2 lectures I'm always extremely looking forward to, because it's super exciting to see what you finally achieved and how you're presenting it. And I think it's also a good moment to see what your colleagues have been working on and what they've achieved, and potentially maybe have some follow-up work because you think whatever your colleague did was amazing and you want to learn more about that. The projects themselves are being done on your own. I do not want group projects. I want you to discuss with your colleagues, but I want each and every one of you to implement something on your own. Please make sure that you don't overestimate the amount of work that you can pull off. And you will have many ways how you can discuss with us, but I strongly believe that if you work on something on your own, it's the kind of, you get the best learning experience out of it. In group projects, it can sometimes happen that some person does not fully understand everything, and then the other person jumps in, and then the learning experience is kind of impeded a little bit. So I do not really want that here. That's why I want each and every one of you to do their own project. The number of participants in this course is limited. Even though it's an online course, I will admit around 25 students, because I want to give every one of you individual feedback. I will read through your code, I will grade it, and I will have to understand what you're doing. And I want to do this properly. And given that I also have a full-time job here, I'm not able to do 50 or 100 students each semester. If there are more than 25 students that are interested in this course, some of you might have to wait until next year. And at this point, I would also like to direct and appeal to you and your fairness, that please only sign up for this course if you really have the resources and are willing to take this course. The last 2 years, it happened that a lot of people enrolled and they were interested in this topic, but they didn't kind of understand that this course will require quite some effort from you. The ECTS are quite correct, so you will be working around 100 hours on average from the reports from the last years on this project. So make sure that you really have the capacity to do this project this year. If not, please unenroll and give someone else the possibility to join this course. I would ideally like that if 25 people enroll in this class, that I will hand out 25 certificates at the end. And finally, there is another course this year that has been entered to TIS as a preceding course called Deep Learning for Visual Computing. And I would like to say a few words about that. It's an optional course, and the reason is that there is quite some overlap between visual computing and like deep learning for visual computing and applied deep learning. And the difference here is primarily in how the course is structured. Deep learning for visual computing will give you an introduction to deep learning and will go really deep into the visual domain, into visual computing. And you will do projects on image classification and also get hands-on experience, but you go into much greater detail than I can in this course. So in contrast to that, applied deep learning course will also be hands-on, but is of a much broader scope. So I will give you not only information from the visual domain, there will be a lecture on visual computing, which will have some overlap with the other course, but I will cover a much broader field. And if you are interested in deep learning, I can absolutely recommend to also take that course. If you haven't taken it yet, take it next semester. It's a great course, and I absolutely recommend it also as a continuative course, because you will learn much greater details, for example, about the backpropagation algorithm that I simply do not have the time to cover in this class. Finally, when you're gonna train your own machine learning models, I unfortunately do not have the resources that I can give you a big server or something to train your models on. So you will have to bring your own computing resources. Luckily, many computers that people have nowadays are already suitable. So you can run some of these models on your local hardware. If you have a graphics card that is CUDA enabled, there is a high chance that you can even run them really fast. But even if you don't have any of that, there are online resources where you can even run machine learning models for free. For example, Google Colab is a great resource. I will also share many of my examples through that platform, where you can run machine learning models even on GPUs and TPUs, tensor processing units, if you've never heard about that. And they will run very fast and it's for free. It's great. I can absolutely recommend it. There are similar offerings also from other vendors like Microsoft and Amazon that you can check out and use for your projects. That covers everything I wanted to say about the logistics and about the applied deep learning course itself. And now let's head over and jump right into it.